Hello everyone, this is Ashish and welcome back to Spacecast. And today we are going to talk about a lot of interesting things. We want to discuss James Webb Space Telescope, just like you have been requesting it for a long time, and I cannot avoid it. You have been requesting it before the launch date, and now it is at the proper orbit, the L2 halo orbit, and it's cooling down. Thankfully, the science missions have not still started, so we are not that late. I want to discuss that. Another thing that people have been haranguing me about is the review of what was that? Yeah, Rocket Boys. I did watch it, truth be told. I was planning not to watch it. All right, I watched it for you guys, so maybe it's a good time to hit like. And thank you. I want to thank you guys for suggesting me. I was just thinking that this is again another mission Mangal. I'm tired of those things that they just dramatize too much. No science over there. Actually, there was not much science over there. I'm going to talk about that later. But overall, kind of the best Indian space science technology related to ISRO or BARC that was created so far. And that was a web series. Who would have expected? The Bollywood, man. Bollywood could not create a movie as good as this one. Anyways, we are going to talk about technicalities of that. As you know, I like to stick to the technicalities. Same goes with that one time when I tried to explain rocketry trailer, the Vikas engine technicalities as much as I could explain. That's what we stick with. But we are going to start with JWST. And there's a lot of things to discuss over here. And one by one, you can think of it as a lecture, as a person sitting next to you, explaining one by one the things that you need to know. Okay, now let's just accept one thing. You're not going to understand it to the point that you create your own telescope and leave it at the L2 orbit. People have spent decades on this, careers on this, and this is one of the most complex space program or mission that was ever created. And definitely there are much others as well. For example, the Apollo missions, we cannot really argue with that, or the Voyager. But this one is also nonetheless very interesting. Now, my relation with JWST is kind of strange. So I know that it has been on news since the Christmas, right? And everyone has been talking about it. But I never kind of got the interest towards that, because my interest when it comes to space science and engineering is more focused towards propulsion. And that's what I want to study more and more about. I would rather study the propulsion of an airplane than a telescope. But then, whenever I got into it, it was so interesting that I cannot just leave it. And so I kept on studying more and more. But then when I stopped studying about it and 1 and 2 days passed by, I can't just get myself back onto it, because I'd rather study something related to propulsion. But then again, when I got into it, it's again hooking me in. All right. So obviously a topic so technical where people have spent their careers, I would not do the disservice to just talk about it randomly, just blab about it. So I made solid notes, things that I want to cover. More importantly, because I don't want to forget a point or two, because this is going to be recorded in lifetime. There's going to be no cuts. It's just like a conversation. You can also think of it like a lecture, but I do not think of myself as competent to give a lecture on James Webb Space Telescope. But what my objective is going to be is that anyone should be able to understand what this is all about. And some of you guys might be thinking, what is this all about? And when you get into it, there's so many technical terms, and they're just, because of redshift. What is redshift? You just get into it, and because of thermal radiation, electromagnetic waves. What are these terms that you're throwing over here? I cannot understand anything. By the way, it's super hot, so I'm going to take it off. It was not a stunt that I was planning, but you understand. It's getting hotter over here. We are getting closer and closer to summer. So, coming back to the point, my objective over here is going to be that I can explain things in a way that even people who do not understand anything about JWST can understand. But obviously, we are not going to stay at 8th standard physics and maths over there. We are going to understand what are its objective, and that is basically how I teach anything. Let's start from the ground level, build it up to a point that when you reach that high level, you think that everything is easy, because that's how it has been gradually developed. Now, without any further ado, these are the things that we are going to talk about when it comes to James Webb Space Telescope. First of all, we are going to discuss why do we need it. Then there's a very important comparison, that is, why do we need it? So we'll have to compare it with the Hubble telescope. And then we are going to get into the trajectory that it has been for 1 month. Now it is in a stable halo orbit, but what was the whole journey, and when it is going to be functional or commissioned. Then we are going to talk about the telescope itself, the proper engineering of that. What is the sun shield? I always mess that up. What is the sun shield? We are going to talk about how it captures images, image processing basically. And then ultimately there's a propulsion in here as well. And finally, I want to end with what I can say, orbital mechanics of that. So in any spacecraft, orbital mechanics is extremely important. That is how you fly around objects across the universe with minimum amount of energy, and you'll have to understand how the gravitation of the celestial bodies in a universe works. I've explained this before. It is not like, okay, I'm sitting in a car, I have to go left, I'll steer left, and I have to go back, I'll push the back gear and I'll reverse it. It's not how it works over here. Orbital mechanics is simpler and complex at the same time compared to what you have over here on Earth, where the gravity is only majorly from one single body. So more importantly, we are going to talk about what is Lagrange point, the L2, where JWST is sitting right now, or orbiting around the sun, or orbiting in a halo orbit which is orbiting around the sun. Why did we choose that? Why is it a stable point? And finally, we are going to talk about what is special about L2 and all those things. I think these things will be sufficient for you to understand what is JWST all about from an amateur point of view. Obviously, we can dedicate further Spacecast in talking more and more about it, but I kind of have a feeling that maybe we'll not be able to cover all these 4 topics in today's podcast itself, but we are going to do the most. Since it's free for me and you both, we sure can afford more than 1 episodes over here. But one thing that we are not going to compromise is the quality of what you're trying to learn over here. Like I said, basic learning. There will be no questions unanswered, and your questions are more than welcome down in the comment section. Okay? All right. So get up and we are going to start. 1 second. My lips are drying and my mouth is drying. Okay, so what is JWST? What is James Webb Space Telescope? So by the way, James Webb was the administrator of NASA during the times of the Apollo mission, 1961 to 1968. They decided to give the honor to him by naming it after him. Okay, now what is it? It's a telescope, obviously, but in a simpler terms, it's a camera. You want to shoot pictures of distant places of this world or the universe. Now, Hubble telescope was the same thing. It's kind of the higher, more upgraded version, or also like a replacement of Hubble Space Telescope. So what do these telescopes do? They take pictures of distant places. For example, you might remember one time I explained about the farthest place in the universe, the picture of which we have, and GNZ 11, I think the name was, if I remember correctly, and that was taken by Hubble Space Telescope. And that picture was taken just 400 million years after the birth, that is after the Big Bang. So how can we see that? Well, obviously universe is so huge and light speed itself is too small that it takes years and years for it to travel from one distance to another. So the photon created at that time is reaching us now, or reaching the Hubble's telescope now. So now we can see. So what we are actually seeing is what happened 13 billion years ago, right? So that is why a lot of people are calling it time travel machine. That is so stupid, man. It is like cringe thing to see when I see that as clickbaits on YouTube. So it's as simple as that. You are basically seeing the past because it takes so long for the light or the information to travel at the speed of electromagnetic waves, right? So we are trying to see distant images. And why is James Webb Space Telescope so special? For that, we'll have to talk about Hubble Space Telescope. So Hubble Space Telescope basically operated in the UV and the visible spectrum. And for you to understand that, we'll have to first talk about what are electromagnetic waves. Now, electromagnetic waves carry information. What we see as light is a very small part of electromagnetic waves. And more specifically, it ranges from the spectrum of 0.1 micron to 0.7 micron, micrometer, 10 to the power minus 6. Now, this range is the only range that our eyes are sensitive to. Everything else is invisible. That is why nuclear radiation hits you and you can't even see that it is coming because it is not in the visible spectrum. Now, here's the thing. If you look at electromagnetic spectrum, I'm going to put the picture over here. That is why I said that Spacecast, it is important for you to get the video version. So I'm going to start from the shorter wavelength to the longer wavelength, and wavelength is as simple as the distance between two crests. So it moves in the form of waves, right? So first is gamma rays, then is X-ray, then UV rays, and then visible light spectrum, and then infrared, and then radio waves, right? So now is the problem of redshift. Now what happens is, like I said, a photon or a light wave or an electromagnetic wave, it's not wrong to say radiation, but we are going to stick with that now. So it has stayed in universe for as long as it has traveled in the universe. So let us take the example of the GNZ11, that it has traveled across the universe for 13.4 billion years, right? So it has stayed in universe for 13.4 billion years. So what happens in the universe? Universe itself is expanding. So whatever stays in the universe expands. And needless to say, staying over there for 13 billion years, the waves itself expands. So in the simplest way, the blue color or the violet color has the shortest wavelength in your rainbow color list, right? Whatever the white light is comprised of. So it is the shortest wavelength, smallest, so 0.1 micron. Now, if that violet color stays in the universe for long enough, its wavelength itself is going to increase because of the expanding universe. And very soon you are seeing it 0.7 micron. That is, now it is red. So the violet has shifted to red, and this is what we call redshift. That is staying in the universe long enough. The universe itself is expanding. So the electromagnetic wave is going to expand in terms of wavelength. The color itself is going to change. Okay guys, I just want to add this one part because I really hate when I'm giving partial information, and there should be no misinformation, especially when it comes to science. So this is one of the ways of explanation. It is not perfect. It is not 100%. Some would say it is not even correct, but it is a good way to understand things like universe is expanding and the waves itself are expanding. But there's another way of explaining it that is analogous to Doppler's effect. Doppler's effect, basically a car moving away, its sound effect fades away. So in a similar manner, the light also faces a similar fading away. Like think of it like the wavelength fading away, expanding. So every point in the universe is going away from you, right? Because the universe itself is expanding. So because of that, the light source is running away from you. And a light source which is running away from you will always seem red. On contrary, a light source which is moving towards you is always going to seem blue. So I'm going to make a separate video explaining this properly because it is impossible to explain it without diagrams. So that's it, just information that you should know of. And let's get back to the podcast. So the visible spectrum, what you are seeing might not be of the same color of what it is. But thankfully, we know what is redshift. We know how long it has stayed over there. For example, the light that came from GNZ 11 was 13.4 billion years old, right? And that means that it is 13.4 billion light years away. Now, I'm going to mess up a lot of times light years and years, but light years are basically the number of years it takes for light to travel from one point to another. Speed of light is same as speed of electromagnetic waves, is 3 into 10 to the power 8 meter per second. So 13.4 billion light years away GNZ should be, but it's not over there because it is now actually 32 billion light years away because the universe is expanding. So how can we know that? Because we can calculate how it is expanding, how far it was, when it was, and where it is now, right? So this whole talk is going to be very much inclined towards astrophysics. I know that there are a lot of fanatics of that over here. It's not my specialty, but I'm going to do my best to explain it to you guys. Okay, so it's a big problem because if violet is shifting to red, what if it shifts on the infrared side? Now you can't even see it, right? So Hubble Space Telescope did have certain infrared capabilities, but most of it could not register. And that was the limitation of it. But James Webb Space Telescope mainly works in the infrared region. And that is why it can see farther. Because whatever came from farther than, let's say, GNZ 11 is going to be having much more redshift. And by the way, GNZ 11 also was a very lucky shot, that it was luckily in the clear path. A particular galaxy acted as a lens, and then it was able to get the best picture possible. Maybe they will never be able to take a certain similar picture again. But James Webb Space Telescope is much more focused towards infrared. That means they will be able to see farther and farther. There are other differences as well, which we are going to obviously talk about, that why it is so capable, right? But one by one we are going to discuss that. So this is one difference between James Webb Space Telescope and Hubble Space Telescope, that the way that it operates or what it is targeting. And that is why it is called like a time traveler, or it will be something that helps us understand how the universe came to be, because it will be able to see that far. Now, it is still going to be a couple of months till it starts doing science missions. I think June is the time when it will be commissioned. It is very successfully deployed, by the way. And that's a big deal because it was not an easy mission. And one by one, when you understand the complexity, you'll think, oh my God, was that magic? And you might as well call it magic. But science is magic. And we are going to discuss how this magic actually works. What are the tricks? Okay. All right. Meanwhile, any questions, goes down in the comment section. It is exerting, talking continuously. It's not an easy thing. And plus, I've been out of the business for a long time. And what's that? It's already overheating. Maybe the reason is that it is plugged in. Let's try that. Okay. Let's see how long it is going to go. Otherwise, we are going to take a break after some time. Okay. So what is the other difference between James Webb Space Telescope and Hubble Space Telescope? What are the other differences? Number one, it is farther from Earth. That means farther from Sun as well. And why is it good that it is farther from Sun? Well, it is cooler now. Now, Sun is filled with photons and it's like the closest source of light, right? So you know that if you are in a city, you will not be able to see the stars that well. Why is that? Well, because your eyes are all blinded by the lights around you, the lights of the city, the street lights or the houses lights and all those things. You can also say that your eyes are saturated from the light of the places all around you. That is why you're not able to see lights from a distance. So that star, which is millions of light years away, might be very bright, but at the same time, it's far away. So it is very dim. So the amount of light that is coming to your eyes from that star is very low. So you'll not be able to see it. And better way to explain it would be you'll not see the stars in the daytime. Right. But what if you go to the countryside, you go to villages, and then you'll be able to see stars better because now your eyes are not that saturated. So in a similar manner, when you place a telescope or a spacecraft far away from sun or farther away from sun, it is in a better position to see much more distant objects, because distant objects automatically will be having very low amount of energy or electromagnetic waves transmitted towards you. So you'll be kind of in a shadow trying to look a distant place. That's the whole simple science behind that. So if you do not know, the numbers are Hubble Space Telescope is at a distance of close to 500 kilometers from Earth, and James Webb Space Telescope is at a distance of 1.5 million kilometers from Earth. It's farther away than even Moon, which is close to 300,000 kilometers. So that is one big difference between the Hubble and the JWST, and that is what basically makes it a lot better. The second big difference would be that it is a lot bigger. Now, a lot of people have been using this comparison as big as a tennis court, right? Well, the actual numbers are 6.5 meter from end to end. Obviously, it is not a circle, so I cannot use the term diameter. But if you look at the area, it is 24 meters square. So it is bigger. Now, why do we need bigger? Well, obviously, if you have bigger mirror, then you are going to capture more of light that is coming from the distant objects. So the scientists actually wanted it to be a lot more bigger, but they could not because of the limitation. So if you look at the biggest carrier that we have, that is the Iron 5 of ESA, then it is having only a diameter of 5.4 meter, right? The payload capacity, I'm talking about that, the diameter of the payload. So it is only 5.4 meter in diameter. And as you can see that we are already having a bigger telescope. So it is a big old folding mechanism. And what do we call it? That paper kind of thing that we do. I'm forgetting the name, but it's a big thing these days when it comes to science and engineering, because they are just exploring that. Came out from Japan, I think. But anyways, they had to fold the whole telescope and so that it can fit in the payload bin of ESA's Ariane 5. So they want it to be as big as possible, and since it is already bigger than Hubble telescope, so obviously it is much better. And the third one is that its sensors are more focused towards infrared. So because of these three things, it is going to be having much higher capacity than the Hubble telescope. And that is why it is much better. Now you have to... Alright guys, we are back. I'm sorry, my camera is having some unusual issues. Probably it will not happen again. This next part I'm recording 1 to 2 hours after I last recorded it, and we are going to continue exactly where we were. I think that we have covered an important part of why James Webb Space Telescope is different from Hubble telescope. What are the main differences, why it is much better, how it is going to overcome the limitations of Hubble telescope, and we ended up discussing why it has to be maximum this big, cannot be bigger because of our propulsion limitations. All right, now maybe Elon Musk will help us out. Now, other few things is that Hubble telescope itself was pretty good. It is still pretty good. There's still some time before it retires officially. And huge difference between Hubble and JWST would be JWST is not repairable. So there are a lot of missions that has already taken place to maybe replace some components of Hubble telescope, maybe replace it, maybe fix some issues over there. The main carrier of that, the one thing that established it, was the space shuttle, which has retired. But this JWST cannot be repaired, mainly because it is 1.5 million kilometers away. The farthest that a man has gone so far is still moon. It's debatable. A lot of people with conspiracy theories argue against that as well. I personally firmly believe that it did take place, and maybe we can talk about that by the end of this podcast, because I went through a podcast hosted by comedians talking about why it is a conspiracy theory, and it seems super stupid to me from the science point of view or from engineering point of view. But that is a topic that we are going to skip for now. Now, I guess that is more than sufficient. Now I want to focus on next the trajectory that it took. And you might be knowing that it started on the Christmas day, 25th of December 2021. Now that was for the Western people, but for Indians it was actually 26th of December, because we are ahead somewhere around 12 hours depending on whether you look at the East Coast or the West Coast. So I'm going to talk about the American time. There are 4 different time zones, but basically based on, I'm not even sure properly, but if I had to guess, then they're most likely talking about the East Coast, which is what makes me a little bit unsure which was actually the launch site of JWST. I don't remember it, and is a question that emerged over here itself. Maybe you were thinking as well. Oh yeah, it was French Guiana, right? So it is ESA's mission. So when they were noting it, I don't really know, but started on 25th December. There are various time zones, whatever it might be. Maybe you can put it down in the comment section, whether it is Pacific time, Eastern time, or whatever. America itself is divided into 6 time zones, 4 in the mainline, 1 of Hawaii, and 1 of Alaska. So I'm not going to put that debate over here. Maybe we can discuss more important things over here. So launch date 25th December 2021, and it just a few minutes of launch, and after that the main target is, now you have to reach the L2, that is the Lagrange point 2. More about that we'll talk, why it is that important, but all you have to understand now is that it is 1.5 million kilometers away from Earth towards the direction opposite of Sun. L1 is the point in between Sun and Earth, and if you have not heard of it, ISRO was trying to launch a mission called Aditya L1, and L1 actually stood for the Lagrange point 1, and that is the point you go towards if you want to observe the sun, study the sun. But that mission never actually came into being, at least till now. Maybe in future it will be. Apart from that, other missions like Venus and all, we never got to see that. Gaganyaan is still on the way. They are trying to get into moon again. So we'll see. One thing that I want to point out right now is that Somnath sir took the seat of chairman recently and replaced Kesavan sir. Now, I do not know if you know that person, and I don't know that person personally as well, but I was fortunate enough to be in a room where he was giving a lecture, more than once actually. And that man is so charismatic, really a person that I really truly believe that is someone, that is the kind of person who should be running a space organization like Indian Space Research Organization. And I'm extremely happy. Matter of fact, I was praying to my lucky stars that he becomes the chairman, because there were other candidates as well. I'm super excited that he's the chairman now, and that really brings my hopes up towards ISRO. 2014 was the pinnacle of ISRO. That is where we saw the Mars mission, Mars orbital mission, MOM or Mangalyaan, whatever you call it. And then the next peak came somewhere where it launched 104 satellites. That was the record at that time. And then we did not see such miraculous mission ever again. But I'm having high hopes, because that person is really something that you should look up to. There's an interview of Somnath sir taken by Shashi Tharoor. So that is one thing that you should definitely check out. That is really one personality that is not as well known as he should be. He's like very young-minded person. Obviously, he's like in his late 50s, but from mind, he's young. Like he would look at someone who is just starting a space organization with big ideas, with maybe not that much of an output, but if that idea is having a spark, something different, he has the vision to catch those ideas. That is the kind of person he is. And there are multiple reasons why I'm having high hopes for him. And not only me, I think almost, obviously I cannot speak for everyone, almost everyone who is currently in Indian Space Research Organization. I'm not currently, I was till 2020 January, but I believe that everyone would be excited for him being at the senior most spot for ISRO. I'm very happy for that. I do not know how I got into it, but okay, let us get back to it. 25th December 2021 was the launch date. On 24th January 2022, it reached a stable halo orbit at L2, and 6 months after that, it will be commissioned. That would be close to June of 2022. After that, it will be able to do science experiments. So the launch time was 28 minutes. And then after 31 minutes, it deployed the solar panels and also the high gain antenna. Solar panel so that it can use the solar energy to run its instruments, and high gain antenna so that it can communicate back to the Earth. There are three receivers and transmitters on Earth. One is in Australia, one is in California, and the other one is in Spain. So depending on the rotation of Earth where it is going to have the transmission flawlessly. Now next, after 12 hours of the launch, the burn started to put it on a trajectory towards L2, and 1.5 days later, it passed Moon. Now, if you do not know, Apollo mission took 2.5 days to reach Moon, and it stayed over there for close to 22 hours, and then again 2 to 3 days to come back over here on Earth. Now, granted, Apollo mission completed the entire mission faster than the whole mission towards the L2, because they have different objectives, because now we have higher technology and we can afford it. We just directed it faster, but the point being that it took 1.5 days to cross Moon, and after 2.7 days from the launch, it deployed its sun shield. Now, sun shield is something that I want to talk in detail, the Kapton material and the 5 layers of it. One by one, we are going to uncover that. And 13 days post the launch, it was fully deployed. And there are so many components because you are basically unfolding the whole thing. And it is not as simple. It is having 300 single points of failure. Anyone does not work properly, then it's going to go out of control. I'm pretty sure that it is 303 or like close to 297 or something. But they just rounded up 300 so that they can fly it around. Another thing is that this whole mission costs $10 billion, man. Seriously. Now understand, $10 billion. Hey, what's the population of this world? Close to 7 million. Sorry. Did I say million? Billion. If I did, I'm extremely sorry. So the cost is close to $10 billion. They were calling it 9 billion. Then again, I'll say that it is a roundup, and population of this world is close to $7 billion. So 7 billion people, right? India has 1.3 billion. Let us check. Yeah, 7.7 billion, right? So if every one of us, everyone, right? And also, you must understand that 7 billion does not really mean 7 billion. There'll probably be more, 7 billion on record, right? So you're not going to literally go from one place to another, scanning every corner, finding out what is the population. So let's just say that everyone gives $1. Can we really afford that? Because $1 for me is close to 75 rupees, right? And that's not a small cost. And you go to other countries with different currencies. So they justified it, if I remember properly, because every scientist involved with JWST project has gotten some spotlight or the other. Someone is interviewing them or the other, and I'm sure that they are having various directions that you should talk about this, you should not talk about this. But I think that I had one analogy where someone said that it is like one cup of coffee for every person throughout United States. I do not know, or maybe all the countries which are involved, maybe Canada, European countries, and USA. But that's what they said. Now that is close to, I would say, 300 rupees. So they justify it like this because people ask, why are you doing this when you can put $10 billion towards maybe curing some disease, or maybe towards the pandemic, or maybe feeding the starving, or maybe there are a lot of things that you can think of, right? So they will have to answer like, what are you trying to do? So ultimately what we are trying to do is explore the universe, right? We want to see far. We want to find out how we came to be. And people are like, why can't you just not do that? Because it is not going to help us immediately. Kind of like Elon Musk. Why are you trying to go to Mars when you can fix a lot of things on Earth? We still got somewhere like thousands of years on Earth at least, and maybe more than that if you fix it over here, right? So why do you need to go to another planet? Why do you need to explore? Why do you need to put so many billions of dollars over there? And they justify it in various ways. Now, one thing that we all should agree is that there has to be a starting point, right? Because these things do not happen in 10 years or even hundreds of years, right? Now, we have not yet seen hundreds of years past of space science because it literally was born after the World War II, not before that. So it takes hundreds and hundreds of years. So someone has to start that. And over that, generations after generations will come and build over that. But if at every point we always think that, why spend money over there, then it never gets started. Now, there are endless utilities of space science and engineering. Now, the fact that you are able to listen to what I'm saying right now is partially because of that. A lot of people do not understand that internet is because of a web that is literally around the world, sitting like a web around the globe, throughout the oceans and the seas as well. But without space science and engineering, there will be a lot of technologies that are not present today. Communication would be so lame, right? So we have it at that. Maybe that can be another full podcast of discussing why do we use it, but I'm sure that you'll find plenty of videos. That is one thing, that you have to start the technology or it is never going to grow. And it might be that we just might find a huge amount of resource in some celestial body. Another reason is that extinction, which is again a far-fetched thing. But let us say human beings are going to be extinct in 10 years. Now today, let us start developing space science. How about that? Today, let us start working on nuclear propulsion. Today, let us start working on how we are going to have reusable launch vehicle. You're not going to be able to do it. Then what? So someone has to start it so that hundreds and hundreds of years later, people are building upon that, right? In a similar manner, maybe today, exploration is not that much of a necessity. But tomorrow it might be. There might be some asteroid that is coming straight to our way. Right, there might be a black hole that is coming straight to our way. Not much we can do about it, but we should know our surrounding, right? Do you live in a house not knowing about the streets around? That's not how it goes. Even so, for example, I've never gone to Ukraine. I've never been to Ukraine. I've never been to Russia, but I know that there's a war which is on the brink right now. I know about my surrounding because that is how I can predict how things is going to look for me in the future, right? Why do you study some inflation going on in some European country? Why do you do that? Because that might affect you, reflect you. So as human beings, we have always studied our surroundings. That is how it works. So studying the universe around us, that makes sense as well. Now, that might not make immediate sense, but over time, when it will start making sense, our lifespans are so limited, maybe we'll not be able to work upon that immediately, right? Okay, now I'm sure that some scientists will be able to explain it in a much better manner, but something that I have not seen anyone explaining today, okay, is that maybe one reason might be that we are just doing it to have fun. Exploration is fun as well, isn't it? So we want to look at the distant galaxies. We want to look at what is happening around. We want to look at the supernovas. We want to look at maybe some planet which is very similar to Earth. Do you know the capability of JWST? So think about a light like that, right? Dimmer than that, which is placed on moon, right? And you are looking at it from Earth. That's the telescope capability. If you have that, JWST is able to do 20 times of that far away. So think of how many worlds we are going to discover because of it. And it's fun. If it is nothing, it is fun. Now, obviously, the NASA scientists are supposed to tell you that, okay, it does not cost really that much, right? Because they'll have to justify the cost, and they'll tell you it's almost like that much money you spend every day. Not everyone, not some starving person in some third world country. I know a lot of them. So not everyone, but one thing that definitely makes sense over here, that it is for fun and exploration as well. How can you not talk about that? And it is something that might cause a little bit hate towards me, but it does not matter because very few people know me anyways. But it's not wrong to have fun, dummy. There's nothing wrong in having fun. Don't you go out on weekend and have a good time with your friends? Do you think about starving kids at that time? Not saying don't think about starving kids. Do charity as much as you can. But don't you have fun? You do, right? In a similar manner, space exploration, I believe, is fun, and people are very afraid to talk about that, and there's nothing wrong with that. Don't you appreciate a good musician? They're one of the richest people on this world. You all know Beatles. You all know top musicians. I say Linkin Park, what it was, Metallica, or currently, if you look at it, maybe Justin Bieber or maybe Maroon 5, whatever. All right, your favorite band, your favorite musician. So we all have fun, right? Every now and then we do. Space exploration is also to a huge extent fun, or exploring distant part of universe is fun. Now, one thing that people do not understand, the vision of Dr. Vikram Sarabhai, right? So if you look at the motto of ISRO, now it was something that towards the mankind. All right, let me just, so that I do not make a mistake in quoting that. All right, space technology in service of mankind. All right, now exploring or finding out a black hole is not going to be an immediate service of mankind. There's no doubt in that. Also, exploring Mars is not something that is going to benefit mankind immediately. Okay, so most of the missions of early ISRO was more focused towards launching satellites in the orbit, right? And that definitely helps you on a daily basis. That helps you in multiple ways. Like even you can obviously you can understand weather, you can understand the crop fields, you can think about multiple use, and the pictures taken by those satellites, a lot of them are freely available. One thing, don't forget, it can be used to avoid war. How is America right now knowing that their weapons or military or 1.3 million people right now at Russia-Ukraine border? Not 1.3, I think 130,000 men at the Russia-Ukraine border. How do you know that Russia is getting into Belarus and putting their army over there as well? How do you know that? Well, satellite images. How did United States find out that India is doing experiments with atom bomb? Satellite images. So it is a great way to avoid war. Well, how do you think French got invaded in World War II? They did not know that they're standing on their goddamn borders. All of a sudden, they were just wiped away in 2 weeks. Why is that? Because they did not know that the Nazis are literally standing on your doorsteps. They just were brushed through. That is how they invaded Poland. You know, when Hitler broke the Molotov-Ribbentrop Pact, and in June 1941-42, Operation Barbarossa. One second. Yeah. So when he invaded, there was a call who were at the front line of Russian western border, and they called to Stalin, and they basically said that Germans are attacking us. Now that is weird to him because they just signed a peace treaty, and what is happening right now? Stalin was speechless for a few minutes. You know why? Because when any country invades another country, the first few things are the demands. I want this, 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 otherwise I'll invade you. There was no demand. And by the way, June 22, 1941. There was no demand from Hitler towards Stalin. He just invaded because he wanted to invade. Had Russians had at that time satellite images, that invasion would have never gone that far because they would have been ready. The time they were crossing the Poland borders, they would be ready at that time itself. So you can really avoid war if you have satellite images. So there are a lot of satellites. Every country is doing that so that they understand what is going on across their border, and space is free territory. I do not know I've talked about this before or not, but during the 1999 Kargil wars, India did not have their own GPS. So, and at that time, the Indian army was at a disadvantage because the Pakistan's army was at a higher altitude. So you do not need to be a military expert to understand the one who is at the top is having an advantage. You're like a sitting duck down below. So India asked for help from United States, right? Because they had the GPS. So tell us where they are. And United States said that I'm not going to help you. These are like being neutral. Neutrality, a lot of countries want to do that. For example, United States was neutral in World War II as well until Japan attacked the Pearl Harbor. They had the neutrality policy till that point, right? So different countries don't really want to get into it until unless they have to. For example, that is the whole thing with NATO. Attack to one means attack to all the members of NATO. So if they basically act like a single country with a single army. Okay. Anyways, so 1999, they did not get the help, and that's when they initiated the Navik mission, that we are going to build our own GPS system. So yeah, space science and engineering is very important. I do not know where I came here from, but what I tried to say over here is that the satellites are extremely important for mankind right now. There are multiple other uses as well. Maybe some other day we'll be discussing that. But exploration of, let us say, Mars or Venus or Jupiter, or just looking at the moons of Pluto. For example, Hubble telescope looked at the moons of Pluto. That does not really help me. All right. For example, man, I do not have a job. I can't really pay my bills. And then NASA's news, hey, we found a moon on Pluto. You're like, God damn it. How does that help me? It doesn't help me. All right. But the news that you are seeing right now is also a product of communication. Okay. Now, where were we? Yeah, it is costly, bloody costly. And it has a lot of uses when it comes to exploration. Does not really help you right away. And but still it is fun. And I'll bet you that you science enthusiasts are going to check out a lot of pictures that are going to come, which will be publicly available. And let's us understand how big is the universe, or how vivid is the universe, how artistic is the universe, how amazing and spectacular it is. And we are going to have a good time. Okay. All right. Now, also, I would say that exploring universe also lets you understand different principles of physics, because there are a lot of things across the universe which is difficult to explain, that why are two bodies or three bodies behaving like that. Okay, now anyways, we are going to leave it at that. I think that maybe we should keep the JWST on a hold for now. After that, I want to talk about the telescope itself. I want to talk about the propulsion, and I want to talk about the Lagrange point, but I think that it is sufficient for now. Not sufficient for today's episode of Spacecast, don't you worry. We are going to talk about other things as well. On a lighter note, we would like to talk about the TV series, web series, Rocket Boys, which is basically story of Dr. Homi Bhabha and Dr. Vikram Sarabhai. A lot of you guys requested it. It's in multiple languages, available on Sony Live. I checked it out. I do not regret it. I did make points of what I want to discuss over here, so one by one we are going to discuss it. Now, before we go any further, I want to let you know that there will be criticizers. All right, nobody is supposed to get butthurt because of that. I'm just putting my opinion. You can put your opinions down in the comment section if you are on YouTube. If you're not, you're on Spotify, you can jump on YouTube and put your comment back over there. All right, so I love this TV series, okay, as a TV series, not as a documentary. And also I do not like it as something that would enhance my scientific learning. Okay, now this is a domain which is a coalition of nuclear science and space science and engineering. Okay, so if you expected that I'm going to learn something about nuclear science and I'm going to learn something about space science, you're not going to learn anything. Okay, you're going to learn much more on Spacecast. If you want drama or story, then it is good. If you want it to be 100% historically accurate, I don't think so it's the best place. But nonetheless, if you like space science or nuclear science or both or either, I think that you're going to have a good time. Now, I personally had to sweep by or jump from one part to another to avoid some drama, because I'm more interested in history. I'm more interested in technology. Whatever I watch today, okay, for example, anything. For example, today I was watching this movie called Midway. Okay, now this is basically the part after the Pearl Harbor was bombarded, and what happened after that. Okay, one battle happened between navy fleets of United States and Japan. So over there, I get to see the technicalities. First of all, it is historically accurate, point by point, date by date. I know what is happening when it is happening. Now, there are a lot of contradictions, that there are a lot of movies which put dramatic effects over there, but the example that I gave is better when it comes to historical sense compared to this one. All right, so kind of all the movies and TV series do a terrible job when it comes to being historically accurate, but some do better than others. Another one is that knowing the technology. Okay, so at least when I'm watching Midway, I'm seeing the torpedoes getting dropped, I'm seeing the World War II airplanes, I'm seeing the insides of that, I'm seeing a lot of technical things, which is very enthralling to me, and I enjoy that. But that's not what I see in Rocket Boys. Rocket Boys mainly focuses on the story of Dr. Vikram Sarabhai and Dr. Homi Bhabha, and more on Dr. Homi Bhabha. Now, I do not know if you know that, but I've worked in Department of Atomic Energy from August 2017 to October 2018, and I worked in Department of Space, that is Indian Space Research Organization, from October 2018 to January 2020. Okay, now sometimes I confuse that, did I say what I wanted to say or did I say something else? In those cases, you'll see a ding and you'll see the correct quantity over here. Okay, so not only the fact that I have worked over there, I was always passionate to work in these places. At least I can say that with 100% surety about Indian Space Research Organization. And I've studied a lot of history, especially from books. I would name few. One, History of ISRO by Armudan, The second one, obviously, Wings of Fire, very famous, Dr. APJ Abdul Kalam. And the third one, which I'm right now in the middle of, Ready to Fire. And that is, I think, by far the best book on Indian space history or rocket science in general, because it really, really focuses a lot on the technicalities, like how are these engines developed. And the one thing I like about history, that is why I like the combination of history and technology, is because these technologies were at the birth point in the history, right? So you can really see how it started, and that is the easiest for you to understand. For example, right now, if you look at the jet planes, right, fighter jets, it's so complicated, man. If it is so complicated, but if you look at the fighter jets, let us say P-47, P-51, you understand a lot of things because it is simpler, right? It is weaker, it is not that technologically developed, but it is still something that you cannot make on your own today. So that is why a combination of history and science is always interesting to me, because it teaches you things in a very basic manner. So that is what I wanted Rocket Boys to be. By the way, terrible name. I can't I can give you at least 10 names that would have been a better fit for this one. The one name that does not fit is Rocket Boys. First of all, Homi Baba had nothing to do with rockets. Now, you can say, hey, there was a combination. Actually, ISRO or INCROPAR at that time was a part of Department of Atomic Energy, and Sarabhai was kind of like a disciple, and then Sarabhai took over Department of Atomic Energy. All those things I understand and I already know. But majorly, Dr. Homi Bhabha had major part to play with atomic energy or India's nuclear program. Okay, so name given Rocket Boys to these two gentlemen does not really make sense. Okay, also, first season at least talks nothing about rockets. Okay, it ends with a sounding rocket launch, the last episode. Other than that, it starts with a kind of test that Dr. Vikram Sarabhai is trying to do. Not doctor at that time, he was at Cambridge in the first episode, and he's just showing his passion that he's trying to launch a rocket which fails miserably and lands in a ground in Cambridge, something like that. Other than that, there's nothing rocketry going on over there. So maybe you can say metaphorically, these are Rocket Boys. Better names, guys. Come on, you can be more creative than that. But anyways, moving to few points that I've noted down over there. Now, it is oversimplification. Okay. Now, you know that few movies, especially Bollywood, when you watch it, they say things that you would have never said in real life. Like for example, so you met your friend and hey, what are you doing? It's such a lovely morning in Indian Institute of Technology, Bombay, right? You would never say that if you're actually a student in IIT Bombay, right? But the movie has to make the actor say that so that you understand it is going on in IIT Bombay. That's the way of direction that Indian shows have, which I don't like, which is also something that you are going to see over here. Now, this whole TV series could have been concluded in, I think, 4 episodes if you really focus on technical part or even the history or the story. But maybe you have to look at the crowd of India. Maybe some people have difficult time understanding a lot of things which might just work in other shows like Hollywood or something. But it is kind of oversimplification in a lot of part. Like, that is the reason why I had to drag the, what do you call that? Yeah, I had to just jump 5 to 10 minutes like, okay, I get it. Okay. All right. Now, the second one is heroification. Okay. Now, I have no doubts in my mind that both of those gentlemen were heroes of this country. They made this country technically sound. Today, if India is a nuclear power and India is a space power, reason is those two people. Okay? No doubt in that. We know that. And that is why I do not want the heroification in the TV series. I personally don't want that. You might want it. I want more focus towards what they actually did. I already know they are heroes. But maybe then again, like I said, see, the enthusiasts are always going to be disappointed. For example, pick any movie, pick any space movie. The space enthusiasts or scientists who are actually working in that domain will be like, man, it's not that simple. But it's easy to complain because movies do not make their bank, or TV series do not make their bank from you little 0.01% of enthusiasts. They are trying to hit the common crowd. So I can't really blame them. Okay. But yeah, like what I'm saying is that what I want was they should be focusing more towards towards science or towards maybe history. But then again, maybe it would not be liked by so many people. Okay, yeah, one thing is for sure. Now, I've done one review on this channel itself about Mission Mangal. That movie was garbage compared to this. And if you look at those reviews, I'm kind of positive. See, one thing is for sure. I can be the critic, but I always love that they make something about space science and engineering or nuclear program or something scientific. This country already lacks those movies. For example, how is it even possible that nobody made a movie on Dr. APJ Abdul Kalam? How's that even possible? Never came into your mind? What the hell? It never came into your mind. So I'm always happy that they made a movie. For example, I was happy when they made the movie Parmanu. I was happy when they made the movie Mission Mangal. I was super excited when I found out that they are making a movie Rocketry on Nambi Narayan. It never came to be. Maybe in the future. But at least I'm happy that we have the book. Now, that is in a similar manner, I'm super happy that they made this TV series. Okay? And it is much better than Mission Mangal. Like, the drama is much lesser. The sound effect, I liked it a lot. Other than that, I like the direction. I like the acting. I do not know the name of the guy. I know that he's kind of famous. All right. He was in Padmavat, I would say, right? What is his name? Jimmy something? Jim Sharp. All right. So I liked his acting. I even liked the acting of the guy who played Dr. Vikram Sarabhai, because this is the kind of character that I would imagine them to be. Dr. Vikram Sarabhai being kind of like that decent guy, right? And I have not read a lot about Dr. Homi Jahangir Baba. It has one book about him. Maybe I'll take out some time to read about him someday. So I can't really comment over there. But Dr. Vikram Sarabhai, again, I've not read a book dedicated to him. But that's a good thing, actually. Because when you read about a person according to the words of someone else, like how did Dr. APJ Abdul Kalam say or think about Vikram Sarabhai? What did Nambi Narayan think about Vikram Sarabhai? Or what did Almuddin think about Vikram Sarabhai, right? So that really gives you a perspective. And when you read three perspectives, they are matching, and definitely that person was like that, right? They never got to show the dedication of Vikram Sarabhai, or what a nice person he was. Like how dedicated he was towards the scientists, or how friendly he was. Like he was the guy who would go and talk directly with the Prime Minister, with Indira Gandhi or Jawaharlal Nehru. He would make one call to Indira Gandhi and the things would be done. There was no doubt in that. So he was that level, he was having that level of reach. At the same time, you would find him in Chappals, in Trivandrum, talking to his young scientists like Dr. APJ Abdul Kalam at that time. So he was on the foot, he was on the air. I like this quote so much. It is written in the book Ready to Fire, right? In the words of Nambi Narayan. He said that much like his dreams, his body was often in the skies, something like that. I've put the exact quote over here. But the reason was that he was always traveling. He was traveling from one part of India to another part of India. He was running the physical research laboratory in Ahmedabad. He was at one point the chairman of Department of Atomic Energy, so he was in Mumbai, and he was also running this Incopower at that time, ISRO now. So he was every now and then in Trivandrum doing so much things, and also above all he was every now and then in United States trying to get back the Indians who have graduated over there or have done masters or PhD over there from Indian background. He wants them to come back and work in the Indian space program. He brought so many of those. He was trying to have some technical deals, maybe. I'm not sure about that, but obviously a lot of Indian technology today had some of its help with some other countries. You can look at it, for example, the Viking engine, from which the Vikas engine is derived. It's a French model. The first cryo engine was a Russian model, the C20, cryogenic engine C20, right? That is a thrust of 7.5, I think. Later, they made an indigenous one, which is right now used in Mark III. So obviously, he was working towards that as well. He died in 1970, unfortunately, December of that. But before that, also, he was working towards that. For example, he sent 5 scientists to NASA, including Ahmedan, to learn the basics of sounding rockets, or how you are going to establish a telecommunication with that, how you're going to get the atmospheric data. So these were the things that he was always working on. That is the image of mine of Dr. Vikram Sarabhai, but we did not see that. Now I do not blame Rocket Boys for that. Why? Because the first season ended pretty soon. I'd say the time span was till the point that Homi Bhabha was still alive. So obviously it is before 1966. So obviously it has not started well, but I hope that they show it in the next season. Now, other things that I want to talk about, this one was, it's boring a lot of times. And the reason why it is boring, see, they try to put love angles all the time, man. I know Dr. Vikram Sarabhai was married. There must be some relationship going on for Dr. Homi Bhabha as well. I don't want to see it. I do not know why. It's not a love story, man. Why are you trying to make one? Yeah, lot of things goes in a life, if in a man's personal life. I want it to be focused more towards history and science. But that's me. But also, I do not think that you would want a love story in a movie made on India's nuclear program and space program. Let me know down in the comment section if you're on YouTube. Do you want to see that? I don't. All right. So I do not need to see it, and I think that was a skippable part, which could have been replaced by actually what they were trying to do. For example, they just showed the launch of the sounding rocket, right? A person who does not know about anything about space science and engineering or sounding rockets, those people who do not follow Spacecast, would not understand what happened. They don't even know that there's a solid booster inside. They do not know how much Dr. APJ Abdul Kalam worked on that. They do not know how Dr. APJ Abdul Kalam increased the capacity of these booster stages of Rohini rocket. Later on it came out to be. Earlier they were just calling it sounding rockets. And increase the diameter, increase the capacity, and how they later on turned this sounding rockets launcher into the first stage of ASLV, augmented satellite launch vehicle. All right. So you could have shown that, right? You could have shown the technicalities. You could have shown what they were trying to do. You could have shown what was in the payload. Rather, they focused more on patriotism. Now, I do not have any problem with that. And any country would go patriotic about these things, right? And there's nothing wrong in that. But you could have talked about those things so that kids today learn about what they were actually trying to do. So if I'm a 12-year-old kid, okay, by the way, I do not know if that series is really appropriate for a 12-year-old kid because there are some adult languages, probably. Yeah, there are few, which I do not think that will be doing any harm. But let us say I'm a 14-year-old kid, which is also not that older than 12 years. But if I watch that, then it is not going to inspire me to study space science and engineering or nuclear science and engineering, but it is going to inspire me to work for ISRO or BARC. Now that I have a problem with, because a scientist must love the technology above all. That is what scientist does throughout the day, throughout the career. So that is, if you want to inspire the next generation, you have to let them know about the technology. You have to let them know how awesome this technology is, how amazing, how spectacular this is. For example, the way that we talked about James Webb Space Telescope, and trust me, we have not even properly started talking about that. But how intricate each and every part is, how much accuracy is required, what are we trying to do, how amazing it is what we are trying to do, what are the benefits, why did we choose Tumba, why is magnetic equator so important. Maybe they could have explained that. Those things are only explained in documentaries, which unfortunately sometimes becomes too much for kids to understand. But if you explain these things in the form of stories, it would have been much better. But anyways, like I said, I'm just criticizing the things that they should work upon, or maybe they should have hired me to direct this movie. But then again, 4 of you would be watching it because I would have made the super technical, right? Okay, anyways, other than that, yeah, like I said, drama is there. And see, one thing I'll say, that it is less drama than any Bollywood movie, which I really, really appreciate. Here it goes. I really, really like that part where it is not as dramatical as most of the movies like Mission Mangal. Parmanu was definitely better than Mission Mangal, but sometimes it was dramatic. And yeah, love angle. How about we bring love angle in every movie? Parmanu actually did not have proper love angle, but there was a girl. Yeah, we all know what's going on. Okay, so have me next time. Okay. Yeah. Good that I've written it over here. Sorry that I just bursted out your ears. Now, a great movie, a series, web series, a great example of what I wanted Rocket Boys to be like is Chernobyl. That's what I want from a series, which is in technical domain. Now, if you have watched Chernobyl, don't you now know why our RBKM reactor explodes? Don't you know that? Why don't you know that there are solid graphite moderators over there? Don't you know how many days it took, day by day? What happened? Year by year, what happened? Don't you know that? You know that. It does not have drama. It has solid acting, great direction, scientifically accurate, and explained scientifically. Now, I do not remember how many episodes, but the last episode of Chernobyl was amazing. It was spectacular when it comes to explaining how nuclear reactor works. The easiest of terms, man. And it made sense. It is not like you are explaining over there, or you're speaking so that I, as a viewer, understand. He's speaking in a way that the jury understands or the court understands. And obviously, the court is not filled with scientists, so he's going to explain in a very basic manner, which I understand as well. So it seems natural. That is the direction that you could have given, and you cannot say that the Indians would not be able to understand. Yeah, we're one of the smartest bunch of people in this world. What are you talking about, guys? We have more engineers produced every year than United States have in total. So definitely we would have a crowd that will be able to understand, appreciate, applaud to that kind of series. So next time hire me, Rocket Boys. Okay, now so yeah, that's all that I wanted to say. Now with that said, will I recommend you to go and watch it? Absolutely, but keep your hands on the seek button, and whenever you're getting bored, jump off. Do I think that Sony Live subscription of 149 or something, not not sponsored by the way, guys. By the way, if anything in my channel is sponsored, you get that include paid promotion in the beginning. It is mind-boggling that there's so many Indian YouTubers not turning that out and taking money from sponsors. That is a crime. I don't know when they are going to understand that the checks are not that strong yet, but it's going to get very soon. And people are just getting away from with that. You cannot sell a product on a channel without the audience knowing that you're getting paid. It is ethically, morally, and legally wrong. So don't do it. But anyways, do I think that you should go ahead and whatever 200 rupees or something, take the subscription? Yeah, 200 rupees worth for a 10 episode, definitely. But do not expect a lot of historical learning or a lot of scientific learning. Will you learn more from it than you learn from Spacecast? Absolutely not. What are you talking about? It is a podcast focused on space science and technology. Okay. All right. Now, will I watch the second season? Yes, sir, I will. Especially if I direct it. No, I'm just kidding. I'll definitely watch it. Now, that's all that I had to say when it comes to Rocket Boys. I'm very glad that they made it. I can be only appreciative, and I can only tell you guys to go and check it out so that more and more people think about making it. Hopefully the drama will reduce or tone down over time, and the science and history will increase so that people know it the way that it was. Okay. All right. I guess that we have been talking for a long time. By the way, that break that we took after 20 minutes, I learned something fascinating. I learned how to not get my camera overheated. So sometimes it is good to have a failure or a stuttle so that you learn something, so that it never happens. By the way, IMDb gave it 9.3, which is great. Hey man, really? That high? Shawshank Redemption. What was the IMDb rating for that? 9.3 for Shawshank Redemption and 9.3 for Rocket Boys. Hey guys, what's going on? Am I the only one? 91% on Rotten Tomatoes, and Rotten Tomatoes did not give any rating. What is this Koimoi? Guys, let me know what is Koimoi. Also, let me check what's going on, man. Is it really 9.3 on IMDb? Can someone explain me? Why did IMDb give it 9.3? That means that, see, that's great, but it's not that good. 1 second. Chernobyl IMDb, HBO IMDb did not 9.4. All right. Is IMDb any good anymore? Okay, let's check few more. One of my favorite movies, obviously, Interstellar. Interstellar IMDb 8.6. Really? That makes zero sense. Let me know down in the comment section what's going on. Is it like it is now localized or what? Like in India you're saying that, or internationally? I have no idea. Maybe I'll do more research on that. Yeah, but Spacecast is going to be much more regular. Matter of fact, all our podcast is going to be much more regular. You were saying that not enough is coming. Well, embrace yourself, because now 2 Momentum podcasts every week. What? Yes, I'm going to record a Momentum podcast less than 2 hours later, and that's going to be live. But this podcast is going to come after that. Also, Talk and Fire podcast every week on top of that moment, Komal is saying that she is going to record a solo podcast of Talk and Fire every week as well. What are you talking about? 224? Yep, your calculations are on point. And Spacecast every week. And I'm thinking of bringing Talk Logs back as well. So are we really talking about 6 podcasts a week? Probably not. But not because we can't record it, more because it will be a saturation. Kind of like saturation would have happened to James Webb Space Telescope if it was at L1 instead of L2, one technical point. Okay. But at least you'll get 2 to 3. That's for sure. That's for sure. And I still have, you can see, bundle. We did not even cover like 20% or the 30% of what we wanted to talk about JWST. Next podcast is going to be next week. And that's about it, guys. Thanks for your support. And one thing that I want to mention is down below in the description box, you are going to find link of a WhatsApp group which is on space, science and technology. And you can join it. Don't ask other topics or other questions. Space, science, technology, if you want to discuss that, join the group, post over there. Let me know what you want to be discussed in the next one or so. I'm willing to form a community. I've started a Discord as well. Nobody is over there because I did not share it. And over time, we are going to get over there as well. But I want a community of people who are space enthusiasts. And that's about it, guys. We'll meet again in the next one. Till then, bye. Don't forget to hit the like button and subscribe if you're really liking this kind of free flow talk. And also don't forget to put your suggestions down in the comment section. Maybe you can put some questions that came in your mind while listening to the podcast. This podcast is not that big now, which is a good thing for you because your questions are definitely going to be seen by me. And I'm going to address it in the next one. And that's about it. Thank you for your patient ears. And I always appreciate the enthusiastic crowd. I'll see all of you in the next one. Till then, bye.